Before we get started, I want you to introduce yourselves to us. Can we start in the back?
Mary Jo Montgomery, School of Technology.
Don't be shy.
Ashley Williams, and I go to EIU.
And you're what year? Freshman.
Ryan Shoemaker, I'm industrial tech major, sophomore.
I'm Mike Flores. I'm also an industrial tech major, sophomore. Grant Kogel, industrial tech major, sophomore.
Jeff Lafredo, industrial tech major, sophomore.
Ryan Balness, industrial tech major. I'm a junior.
John Woodyard, industrial tech major. I'm a junior as well.
Jared Barber, I'm a junior, and I'm a applied engineering major.
Mori Tusi, teaching construction courses at EIU, and all of these students are in construction.
Now, just a point of clarification, industrial technology is our old name. Starting this year, it is applied engineering and technology.
Dominique Jones, applied engineering technology major. And I am a senior.
Desiree Woodson, I'm applied engineering technology major, and I'm a junior.
Thank you. Andrew?
I'm Andy Keenan. I'm the sales manager for the heavy structural units here. I've been with the company 32 years. I grew up in Streeter, worked here in the plant for 10 years, and then I've been up about 23 years at the corporate headquarters up in McHenry County.
So you started at 10 years age, huh?
I started right out of college, yeah, at 21 years of age.
And my name is Dan Kolb. I'm with Andy. We're both vice presidents of the company here. I've been at Prestress for 10 years. I was with another precaster 11 years before that, and I've been in construction supplies for 10 years before that. I know I don't look that old, but I've been in construction for quite a period of time. A few things that I want to do in this, I gave you a little bit of a heads up, and the reason that I asked, to introduce yourselves and all that, because is this program at one time used to be the construction management program? Okay, because once you get done with your gen ed and everything else and you get more into your applied technology studies and stuff like that, where do you see yourselves going? What do you see yourselves doing? What phase? I mean, because construction is just such a whole big myriad of residential construction, project management. How many project management are you thinking? How many in estimating? How many of you in safety? How many of you don't know? Yeah, we're still trying to figure out what we're doing. Now, the reason I ask you that is because, when I was in school, by the way, guys, my degree's in psychology. And I'm in construction for over, 28 years.
Mine's electrical engineering, so I'm closer than you.
So you see what happens is once we get into something and we find something that we like and we start going into the different curriculums and the different courses in the thing, you're probably going to change. You're staying under that banner of applied technology, and there's a myriad of things for you to be doing. You will start out of school probably as a junior project manager working for some company. You'll be doing estimating. You'll be learning purchasing, which I'm sure you're doing in school right now, but you're doing it right now in a classroom where there's nobody yelling at you. When you're out there on the street and you're working for a company, there'll be, I need this now, and how much is this going to cost? What do you mean you don't know? Where are you going to get it? That'll all come with your experiences through the out on the street.
I see one being yelling at them all the time.
Giving you a good base of what reality is out on the street. Safety. When you're in our plant, safety is number one for anybody. Unfortunately, you as visitors will all be wearing beautiful, bright colored yellow vests, which will tell our people that are working right now that we have visitors in the plant. Unfortunately, we don't have enough hard hats for everybody, so we're going to break you up into groups, and we got to make sure that you don't go in areas where you could conk yourself on the head. When you're walking around in the plant, you can see a construction site, you have the best conditions ever. As Andy was saying earlier, here it's either 100 degrees, bone dry, dust flying all over the place, or it just got done raining and there'll be mud all over. When you walk around in the plant, do not walk with your hands in your pocket. Why?
You'll look like a salesman.
Why wouldn't you walk around with your hands in your pocket? you trip, your hands are in here. First thing you're going to do when you trip, you're going to hit your face. And believe me, there's a lot of things laying around on the ground out there. We do our best to try to keep it policed, but in a construction site, you're going to see what happens is guys will use something, and when they get done with it, they'll throw it. And unfortunately, that happens here too. You're going to see a lot of things. Our plant is a structural plant. Now, how many of you folks went to Lombard? Our Lombard Architectural. Okay, this is an entirely different type of plant. This is a pure structural plant. This side of the plant over here is the pre-stress side. What do I mean pre-stress? I told you I'm going to bother the people in the back row. You sat back there. What's pre-stressed? Okay. Before you're done, you'll be experts on the thing. You'll be in this field when you get out of school because that's what you're going to want to do. There's two types of structural precast concrete products. There's two types. One is precast, one is pre-stressed. Precast product is strictly reinforced with rebar and wire mesh. Pre-stressed concrete may have wire mesh in it, may have rebar in it, but it also has strand. And strand looks like, we'll take you outside and we'll show it to you, but it's 7 wires that are wrapped around each other. And when they get out on the beds here, they take it and they stretch this piece of steel. And what's the elongation on it, Andy?
Well, you'll have it to 31,000 pounds. The pull 31,000 pounds, and depending on the length of bed, it can be 12 inches it stretches.
So if you figure a thing starts out at...
7 wire strand will have 31,000 pounds of basically compression on it when they come back together. Maybe 30 strands of it, so you could have as much as 1,000,000 pounds compression when you're releasing strand.
So when you see this, it'll look like a 1/2 inch round piece of strand. When you take a look at it closer, it's got 7 pieces that are wound around to give you that depth. When you put it out on the bed, it's still 1/2 inches, but when you start pulling it 31,000 pounds, it's like a rubber band. It goes thinner and thinner and thinner. And now what happens when you're done with your concrete and you cut this steel? What happens to your concrete? Compresses. The piece will actually lift up because all the stresses are being thrown right back into that concrete. I know this is kind of over your head right now, but you'll see a lot of this out there, and the reason why I'm bringing this up to you right now is that we want you to know what the differences between precast and pre-stressed are. It's going to help you through your entire career because this industry is building. It's a lot more people are involved with designing and purchasing and everything else of these kind of products, and you have to know what they're talking about. Okay, what we're going to do is we're going to divide us in half. Sophomores, how many we have? How many juniors? You 3 guys and you 4 guys go with Andy, and the rest of you folks will go with me. You can leave those in here. Guys, yeah, if we have them. Extra large are over there, extra large. Let's see the one you got. Take it out. Yeah, you just turn this and you'll feel it squeeze on your head. You got one of the deluxe ones. Okay, precast operations are, like I said, are on this side of the plant. And when you do precast, a typical thing that happens with the architect, they have their design drawings, they have their, and then a precaster has to make samples. What you're seeing here is different samples that were made for housing panels. This is a thin brick product, and we used it with an integral color, and we used it with a standard gray concrete. When you see a sample board like that, that's giving the architect the different color variations for thin brick panels that he could do. The other stuff that you see is samples of just stains. And let's take a walk this way. This plant, you'll notice as we walk over this way, recycles all its water. Because when we're pouring concrete, we don't need, pure fresh city water. We can use potable water And what we do is we drain everything and recycle it to our pond out here and reuse it over and over. Concrete and the fines out, and it goes from dirty water to clear to clear to clearest. And then it goes right into our pond. We have well water here that we also can use, but we use what's free. And we like to think we're being a little bit of sustainability here in our plant by doing that.
What type of machine is that?
This is what's called a MyJack. It's the manufacturer's name of MyJack, and what it does is it straddles a piece of precast concrete, and on the top of each one of these pieces have little inserts. And then it clips onto the piece and then lifts it up and carries it and puts it on a truck. Or it'll take it and strip it off the bed. Okay? What's that product? No?
Mesh.
Wire mesh. Wire mesh is put in the concrete to prevent cracking. Or not prevent it, but minimize it. If you don't have wire mesh in a piece of concrete, what happens is once a crack happens, it'll just keep going and separating. With wire mesh in there, it'll keep it from spreading out even more. They put wire mesh and rebar in all the pieces. How many are from Chicago? How many of you taken a ride on 294 or 80 or 55? Ever see this stuff? This is called sound wall. This plant has made over 4.5 million square feet of sound wall for the state of Illinois. We've made it for Missouri, we've made it for Ohio, but you have to understand when you're talking about concrete, you actually get limited to how far you can deliver because of freight. Each piece has to go onto a truck. Each piece has to be delivered to a job site. And you're limited by the amount of pieces that you can actually put on a truck by weight and by size. What you're looking at here is a two-sided sound wall that's stained on both sides. This piece right here, this concrete lip they call it, goes inside the steel beams. And then they put shims in here to prevent it from rattling around inside the steel. This is one piece, then they got on the other side, they keep going all the way down the line. Okay?
Connection between each piece and the other?
No, this will be between a steel beam.
Steel beam.
It's actually loose in that caisson, in that steel beam area. If we look, let's go this way.
Obviously, beams are installed first.
Correct.
These are right from the top.
Correct. The steel beams are actually, if you ever see a job that has just started, what happens is the steel beam might be up 10 feet in the air. By code, it has to be 80% of the height of the wall in the ground. So your beam is actually 18 feet, but you're only seeing 10. And the reason for that is so the wall doesn't do this. Let's keep going. Let's stop over here. I wanted to show you one more thing. This is an area over here that we don't like to really talk about because these are mistakes. These are mistakes that cost us money. This particular project right here, this is a housing panel. As you can see, it's a thin brick housing panel that has integral color. It's not that gray concrete, it's a light tan color, and it radiates through all the joints here. A window opening that's cast into the piece. And as you can see, this is the top of the piece over here, and this is the bottom. Whenever you have a precast piece, they'll cast this in there. What's that for? Your windows will go in here. What will this do?
Water seal.
When water hits this, it'll want to come around here and go, and if you don't have that, it'll go right back into the building. This is called a drip edge. You'll see this on any kind of construction out there. This will be in every type of window and door application. This particular piece looks okay, but it's actually 3/4 of an inch too narrow. Guy didn't use the right end of the tape, you know. Real quick, measured it out and said, fine, pour it. And then quality control comes in afterwards and says, they measure it and they say, wait a minute, this piece is 3/4 of an inch. And this right here is about a $10,000 mistake.
Do you fire them?
No.
Are these welded to the post or?
Yeah, these pieces, as you can see, come over here. You have an integral weld plate cast into the piece. This will be down to a concrete foundation that'll have a metal piece right here, and then this will be welded to the foundation. And then, as you go along, a floor angle. This is a floor angle. Your floors will sit on top of this, and then when this piece goes to the next piece, what they do is they weld those angles together. That means this panel is welded to this panel, and you keep going all the way down the line. If you take a look over this way, you can see the little lifting inserts that are on each piece. Lifting insert doesn't seem like a whole lot, folks, but that one piece down there is rated for 10 tons. That one piece can hold 20,000 pounds of weight. So I got a 40,000 pound capacity with this wall panel. This wall panel probably weighs 27,000 pounds. Why would we do that? Why would we put 2 in there? You're going to run into this all the time. It's called a safety factor. Designers, your structural engineers, and your architects will always have a safety factor into the piece in case one fails completely. If they fail, usually they'll just pop. They won't completely rip out. Okay?
Now this piece in particular, it's sitting like it will sit on the building?
No, this is on its side.
On side. So the final
thing is this will be up like that.
Okay.
The lifting inserts are the top of the piece. This is a little invention that we came up with when we first started getting into, we do a lot of housing in Chicago, and unfortunately the housing market now is gone, but it will come back. And what we did is we designed our own delivery system. Our trailers.
Adding glasses.
Yeah, it looks like a glass trailer, doesn't it? What we do is we take a panel like that and put it in here this way. The lifting inserts are on top. And what we do is we don't allow our panels any more than 13 feet in height. Why? You're right. Mathematically, if you put more than 13 feet, they won't fit in this frame. That's good, but there's another reason, a realistic reason. We're delivering to Chicago.
Highway bridges.
Highway bridges. If you go higher than 14 feet, you won't be able to get underneath these bridges. That's why we put them in trays that are only 6 inches off the ground. So this panel will actually be 13'6". Safety factor, again.
Now are these only precast or prestressed?
These are all precast. Everything you see on this side of the plant is precast. Rebar, wire mesh, no strand in it at all.
Precast can vary some load.
Oh yeah. Yeah, I'll usually...
Do you specify the load varying capacity of the precast?
The structural
the
engineers will do that by design. They'll work with the architect. There's always an engineer of record on these jobs. And the engineer of record will say that wall panel has to be designed. Let's say you're going to put a double T roof on there. A double T roof will weigh 64,000 pounds. So when you do that, this side of the building, this wall panel, and then this wall panel will have to handle 64,000 total. So it'll be 32 and 32. So that means that wall panel will have to handle 32,000 pounds. Now it's up to my engineer to say, okay, that panel is no longer 8 inches thick, it's 10 inches thick, or it's 12 inches thick. Every piece that you see here has its own piece ticket. There's nothing that's duplicated. So the engineer has to go through every single one of these things and make sure the reinforcing is done right, making sure all the inserts are in the right spot, making sure all the integral parts of that are all done ahead of time before it comes into the plant. Okay?
Now for these pieces, there are additional stresses for handling and transportation that in reality they will not be carrying in place. I mean, when you put this in place, it will not carry all the loads. Would you design it for the transportation stresses or the whatever happens?
The worst case scenario for a precast or pre-stressed product is when you strip it out of the form. This concrete will be taken from the time that you put it down into the form to the time that you take it out of the form will be no more than 18 hours. And we'll have achieved over 3,500 PSI in that concrete before we do that. And the reason being is, now remember, that concrete is still green. You pick it up, it still has all of its own dead load holding up by 4 lifting inserts, and you're actually stripping it away from the form. There's suction and everything else that's being on there. That's the worst case scenario that these panels will see. Once they're up, they're in their ultimate design mode. That's the way they're supposed to be. When they're laying down, they're susceptible to cracking and everything else like that. That's why we have a QC department, and before any of these panels are taken out of the mold, they have to break cylinders. And they will not break those cylinders until that concrete has achieved what my structural engineer says it has to achieve. Usually it's 3,500 PSI.
And the stresses at the time when you strip it would be 50% of that, or more, or less?
It's very close to capacity.
Complete.
Yeah, complete.
So not the 28 days thing.
No. It'll be, I'm sorry, when we strip it, normally a precast concrete panel that you see here is 5,000 PSI, maybe 7,000 PSI. We get 3,500 in 18 hours. So we're about 80%.
Okay.
In 18 hours. And then put it outside, and it'll sit outside for a while, and then you'll achieve your 28-day strength probably within 7 days.
You arrive to this high, relatively high, in short time with different types of curing, or different...
We usually use steam curing, or we have radiant heat curing inside the building. And folks, we don't do that because, you know, we want to be nice and putting extra concrete and putting extra, you know, but that's cost to us. The reason we do that is money. We have to turn these pieces over every single day. We have to pour them, and we have to strip them out of the form, and then we have a whole new crew comes in and puts all the reinforcing in, and then we pour it again, and then we strip it out of the form. We have to do that real fast. And the only way we can do it fast is when we use a high-end concrete with no water added to it. It stays what the mixed design is. That's the beauty of a precast plant, and there's always records being kept. If anybody adds a gallon of water to a precast mix, it shows up on a ticket. Out in the field, when you guys go out and see ready mix being poured, it'll be poured and the guy will say, give me an extra 10 gallons of water in there, and that's when you see the concrete flow down and it looks like water. Okay, that's a reality of what happens. In a precast plant, that is not allowed to happen, because there's always a record following it. Okay?
How many times you can use your form?
On a form liner like this, we buy the very, very high-end polyurethane. You can use 100 pours on there. We pay, it's probably 5 times the amount of money as a standard plastic form liner. But our contention is we buy the very high end, leave it down on the bed. We don't have to come back and repair it and all that other kind of stuff, because you pay for what you get. What you
can
pay
use
for.
it for 10 times, 20, 100 times?
100.
100 times. Very good.
Okay?
Thanks.
Any questions? There'll be a test, you know. Written test.
How many different design do you have? Do you make that available to the architect and
The question was, how many different types of designs do we give the architects? Truth be told, the architect tells us, I want a split limestone pattern. And we saw those, remember those little samples we saw up by the office? We make those samples, take them to the architect and say, is this what you wanted? They say no. Then they come up and say, I want this, or else they give us a picture of something. We actually had an architect come to us and they wanted a cedar fence made out of concrete. Sent the picture off to our form liner people, and they made a form liner that matched that cedar fence. So anything like that can be done with precast. Remember, all you're doing is putting concrete in a mold. Whatever that mold face looks like is what your repeat pattern will be. Here's smooth patterns. They call that a steel form because this thing is being poured down in a steel form. That's a smooth face. That's why precast concrete is getting a foothold in the architectural market, because we're offering a structural panel. Remember, you could put floors on this and everything else on this kind of a panel, but we're also giving an architectural face to it.
These are really nice
Well, this is one that for the city of Naperville, they wanted, this is called a 3-part paint system. The painters actually come in there and they spray one color, that tan base that you see, then they physically hand roll the brown, and how many of you folks have ever seen that faux painting, you know, with the sponges? That's exactly what they're doing here.
I did some of that painting in my house.
So you could come out here and do this on here. I see an internship. Now these guys won't like you coming out and doing it. As you see, each one of those steps that they do is an individual person doing it.
Now, is this going to be sealed after the...
No, the stain they use is actually a sealer.
No, I'm with PCI, the factory.
What is this codes or numbers or enumerating system here?
Okay, remember I told you that each piece has its own ticket? That's what you're seeing here. This actually, when you see a set of shop drawings, panel number T86 will be somewhere in that wall somewhere. So that when they load these trucks, they load it so the one panel's here, then the next panel's here, the next panel is here, so that when they erect it, they just keep going down the line. Unfortunately, sometimes this might make it on this truck, and this one might make it on the next truck, and this guy goes and stops for coffee, and that truck shows up first. Welcome to construction project managers.
Now, when you have more than this ticket, you have more numbers here. 175, N1T, whatever. This is more.
Yeah, this is actually a pour date.
Okay.
When the panel was poured, this could be the inspector number.
Okay.
My plant inspector. And this stuff, it could be the north wall first panel.
Okay.
Panel number 1, panel 96 or T96 could be the project designation area. Panel number 175. When you see a set of precast drawings, you open it up, all these numbers will be reflected on those panels. This very likely is my QC department. The first QC inspector who came out here, and then the head of the QC department, before they authorize it to go on the trucks, have to certify that it's okay.
Okay. What are these steel tubes here, or in between?
Oh, that's just a rack.
Rack.
That's just a rack to hold the panels in there. The worst thing you want to do, you want to make sure that the panels are up off the ground, because remember, they're not completely cured when we bring them out here. So if I laid this on the ground and the ground goes this way, that panel could go like this. So we put, that's called dunnage. You'll see dunnage under every panel out here. You'll see dunnage on the trucks too. When a panel's laid flat, it's on dunnage.
Now, when
Right.
you support it in this point and that point, will it make point stresses?
No, it's designed to handle, this is a dunnage point, and I believe they're at 5 feet in from the edge.
Okay.
That's calculated by design. The structural engineer tells our people where to put the dunnage. Because you don't want to put it all the way out on the edge here, because your rebar and everything else might be a foot inside. And your rebar will come up like that. So if the rebar is not on this area, you'll start getting a crack right along there. Very good. That's a stress crack.
How much of marginal time do you have if the weather is not good for painting and doing this?
We have an inside painting booth. That building that you see right there is a metal fabrication shop specifically for precast. Those little plates that we saw on the side, they're made right here. We have certified welders and everything else that have to go through training and everything else before they can actually make these pieces.
Using the brush or spray, what's
On this particular, this is that 3-part painting. What they're doing, one guy is handling one color, one guy's handling another color,
Okay.
and then you see the guy with the towel,
Yes.
like your faux painting. It's exactly the same thing.
Okay.
Let's go into the building. As you can see, the construction slowdown has hit this plant. Typically, we have 225 laborers in our plant. Right now, we're down to about 50. And that is because of the construction industry slowdown. We have, I think it's 19 or 20 acres. The question is, do I think the demand for employees will increase? Yes. In the construction industry,
Anytime soon?
Sorry, folks. Sorry, folks. We just hired a construction management graduate from ISU this week. I do think it will come around. It has to come around. And unfortunately, all the monies that have been going out right now for our infrastructure that we had through what they call the stimulus program has gone out for asphalt.
Yeah.
Bridges will catch up with that. But the thing that triggers everything is housing. When they start building housing, that means there's money out there for people to start buying that stuff. When that happens, the little stores open up, everything else opens up.
Are they planning as the posts? The panels?
Yes, those are concrete posts instead of using steel beams. So they're matching the same paint on those things and they'll slide right down those pieces. Okay, test number one. What's it? What kind? This is what's known as epoxy-coated rebar. This is standard rebar. Standard carbon steel, nothing else. They dip this in epoxy coating on it, and the epoxy coating is supposed to prevent rusting of the steel and popping and deterioration of the steel. You either use epoxy coating or galvanized.
How does this epoxy coating affect the bonding to concrete?
There have been many studies on that, and they're continually going on. The question is, how is the bonding affected by the epoxy coating? Some people say that the bond is to the epoxy coating versus bonding to the raw steel that has all the fins on it and everything else. That has fins, but it's coated with a plastic. So what does a concrete bond to? That's a question that people such as your professor are evaluating, because right now, folks, we have bridges, we have brought beams back into our plant that are over 50 years old. Bridge beams that have used rebar and stuff like that. We break them open and the steel is just like this. Not epoxy coated. It's raw steel and it's not rusted and it's not deteriorated. So a lot of your universities are studying, is this the way to go? Is that the way to go? Hot dip galvanized.
What's the difference between galvanized and
Remember, this is a coating. They take the steel that's like that, they take it and bring it up in sheets and then dip it in a vat, and it's chemically reactive to what's in galvanizing? It's a magnetic charge, an electrical magnetic charge that pulls the coating right to the steel. This is just like paint.
How about the new types or relatively new types of steel that doesn't rust in the mix itself? When they prepare it, not coating or galvanizing, but the mix itself, the mixture of the steel itself doesn't rust inside, outside.
Typically, what we're seeing some of that, we're going to be doing a parking deck in about a month, and they're specifying stainless steel connectors. Now, stainless steel connectors, they go about $8 a piece. For a little piece of steel, it's about like that. Very expensive, but stainless steel does not rust. Stainless steel doesn't have any reaction back into the concrete. When this stuff starts rusting, it actually causes the concrete to split around it. It actually causes cracking of the concrete because it's a chemical reaction with whatever's in the concrete and the steel. That's why they put epoxy coating or galvanizing on it. Little building over there. Hope to God we never have to use it. It's a tornado shelter. And we laugh, but you know what, folks? Every summer you look out over that field there and you can see funnel clouds dancing across the field.
I thought that's a torture.
No, it's not a torture chamber. It's a tornado shelter. If we just look around the corner over here, remember, this is the precast operation on this side. It has its own batch plant over there. Own aggregates, own sand piles, everything else that goes into concrete is self-sustained right on that. That services this side of the plant. You see that big hopper that's over there? That's another batch plant that handles the pre-stress part. Typically in the pre-stress part is inspected by the state of Illinois. So they have all sorts of different requirements, pre-stressed versus precast. Let's go inside and get you out of the cold.
I have a question.
Yes.
So those the epoxy coated rebars are like when we have construction on the highway. Are those the that they stick like out of the ground?
Yeah, when you see like in bridge construction or port in place, you'll see these green bars coming out of it. That's exactly what you're seeing. When you see it, when they cut out a section of the highway and you see all the bars laying flat, that's what you're seeing.
So when are the other ones used?
Galvanized.
Yeah, the galvanized.
What the question is, when are galvanized used versus epoxy coated? We use galvanized because when you use epoxy coating, if you're handling it and you pick it up and you tear that epoxy coating, you have to physically come back and repaint it with another epoxy coating. So you imagine I'm paying somebody X amount of dollars an hour to sit here with a little brush painting all the cracks that's on that epoxy coating. Galvanized, that doesn't happen. It's all a matter of money.
Okay, so
Galvanized is more expensive than epoxy coating, but you can handle it and it's a lot more forgiving.
but it's used for the same thing.
Same thing.
Okay. What are these things?
These things here are a product that's called step wall. It's a retaining wall system. It's a patented system, and we are the licensees. There are 2 licensees in the in the United States. We're one of them. It's a bin wall, retaining wall here. If you're trying to hold back dirt, what you do is you set those samples up and fill the insides up with what they call porous granular fill, which is nothing more than let the water run right out of it. This will keep your embankment from going like this. It's called a retaining wall. These are the forms for that retaining wall.
Pretty much a large version of landscaping.
Yes, yes.
Eerily quiet.
Remember I showed you those flat panels out there, the ones that look real smooth? This is a high-end plywood, probably 3/4 of an inch thick, but what happens is there's always seams when you put plywood together. This is an epoxy coating that levels out all the seams, and you can pour this and it'll give you a flat, smooth finish.
Applied kind of polyurethane on it. Is that
Yeah,
right?
well this is actually an epoxy coating. You can feel it, how smooth it is. This is a standard form liner. Remember the ones that we saw where they're painting them out there? This is what I told you we use a high-end form liner. This stuff, as you see it right here, costs about $50 a square foot. And what you do is you affix this. As you can see, it's affixed to plywood, and then it's got rabbet joints on the plywood that put it together like this and holds it tight. And then we caulk the joints if we see any seams, and then you pour your concrete on this, and then you strip the concrete away. Typically when we make sound walls with 2 sides on them, we make them inside a vertical form. What you're looking at here is this piece here. Don't be afraid. As you can see, these are those wall panels that you saw from outside with form liner on both sides. What they do then is they close this form up to whatever thickness you want. They pour the concrete from the top down, and then on the sides of the forms, in this track and this track up here are vibrators. They turn the vibrators on and the whole form shake. And all the air bubbles and all that from the concrete come up to the top, and it smooths all the sides. Okay? If you leave these vibrators on too long, what happens? Segregation of your concrete. All your stone. What's in concrete? Come on, you're the senior.
What, gravel or something?
Aggregate,
Okay.
sand, Portland cement, and water. And when you call, your mixture is, it's by weight. how many pounds of each one are in there. But if you vibrate it too much, all your aggregates and all your sand will go down to the bottom, and all your water and Portland cement will just stay in that one area. It'll be real smooth at the top, and on the bottom it'll look like somebody shot it with a shotgun. Okay?
Do you use any admixtures?
We use admixtures in here. We use self-consolidating concrete, so we can get away from vibrating. There's an admixture out there, you put it in your concrete, and you put it out there, and it just goes, it goes out real, it settles itself, self-consolidating concrete.
So the one extreme is self-consolidated and the other is zero slump.
Correct.
How do you go in between? What kind of
Zero slump concrete, you can take it, and if you dump it out of the bucket, it will, if you take zero slump concrete and take it in your hand and squeeze it, it will stay like a circle, the shape of your hand.
What kind of products you use for zero slump?
Typically, zero slump concrete will be used for hollow core flooring because it's put through a machine and it's pressurized and then it extrudes it out. So it doesn't need water, because if it has too much water in there and vibrates it, all the cores will collapse and everything else. With concrete like this, or in housing panels, we use self-consolidating because we don't want to vibrate it. Okay. This building is self-contained. It's heated during the wintertime. It has, as you can see, the electronic heating on the side of the walls, the radiant heat. This will stay about 60 degrees in the dead of winter.
So you work in rain, sunshine, or rain?
We work in rain or whatever because we pour inside. Here you can see some smaller sections of sound wall. And you can see on some sound wall panels we've built up the bottom because this panel only has to be 9 feet high. That panel has to be 13 feet high. So you can do your different heights by building up your form underneath it. The question was before about painting. And, all right, where's the door? That's a polyurethane. In this room, I'm not going to take you in there right now, but in this room we have 4 painting bays. We can take the product out of the form, put it on the A-frame, bring it in that room in 20 degree, 10 degree, 5 degree weather, bring it inside, and then paint it before we bring it outside. Because most paints are stains and require 50 degrees and rising before you can apply it. That's how we get it. Keep going that way.
What's this for?
Yeah, this is actually for this is a reinforcement that they're requiring in the sound wall. They wanted epoxy coated stirrups. That's what you see, a stirrup bar like that with the hard bend. And they have not come back and touched this up yet, because when you can see them touching the epoxy up, it looks like a darker green.
Do you use any welding at all?
No. No.
For the rebar?
No.
Excuse me,
Question.
question. What are these called? I know that they're used to like tie them together.
Those are rebar ties.
Just rebar ties?
Yeah, that's what they're called. They're called bar ties in the industry. Those are epoxy coated, because you can't use a standard black rebar tie, which is just carbon steel, on epoxy coating, because there'll be a chemical reaction. You use epoxy coated ties with epoxy coated bars. You can use carbon steel ties with galvanized, and there won't be a reaction. Why is the blocks on top of that? What they're probably doing on that is making an impression in the piece below, and if you don't put weight on it and you pour the concrete, it'll lift the form up. So they put extra weight on there to keep the thing down. That could be for window frames or something else like that too, because if you don't put it flat on the form, they'll call that lifting out of the piece, and you'll see the frame and the form like this. So you weight it all down.
But like you don't want it to stay in there for too long?
No. What they'll do is when they strip this form away from it, they take the blocks of concrete off first, and then they take all the forms away from it.
And then they stand it.
Then you stand it up. Yep.
Also, if there is no weight the concrete, when they're pouring concrete, has a chance to slip through.
Yeah,
from the
but there's
bottom.
probably something in there that they're holding down to the face of the form. And if that's not there, when you lift it, remember, concrete is poured and it comes down with such force, it'll lift stuff off the bottom. This is a system that, this is a patented system that we're working with the inventor. And this will actually go underneath roadways. Right now in cities like Chicago or other places like that, they're replacing or they're widening roads. And what happens is they dig the road out and these big bundles of electricity and phone lines and all that are in these big, huge cables. And unfortunately, when they put them in there, they didn't mark them. So they might have a bundle with 100 cables in there and they don't know where they go to. So typically what they have to do is they decommission the entire line, they put up a temporary alongside, and then they have somebody come in here and take this line and tap it and say, okay, that's phone, and mark it. This one is a fiber optic, this one is cable. We were working with an inventor that instead of messing around with that, take these concrete pieces and encapsulate over that big bundle of cables and then build your road on top of it. Saves time, saves money, and things like that. This is a design by an engineer who has patented it. We are thinking of, we're hopefully taking this throughout the entire United States. It hasn't even hit the streets yet. So it's confidential. No more pictures. No. A form like this will be replaced after one pour. You know, we try to do whenever we can use steel because it's reusable, recyclable, and things like that. But realities, some of these pieces are not uniform in size. Exactly. Because once you pour something in concrete, you have to start watching because this stuff will all start delaminating from each other. Put your hand on here, folks. What? You feel it? It's still curing. Concrete, when it's curing, gives off heat. You take this stuff in the dead of winter, you bring it outside, you see smoke just flying off this piece. Because the natural reaction of the Portland cement and everything else, yeah, I know. Some people may want to lay on this now because you're too cold. Yeah, we can take this off in 16, 18 hours. And this concrete right here will be about 3,500 PSI. And as you'll see, cylinders like this, every single piece of concrete will have at least 4 of these. And then when they break them after 18 hours and say, okay, now you can pull the piece out of here. If they don't get it in 18 hours, what happens? They'll break it in 24 hours. This piece will sit in the form until the quality control department says it's time to go.
Do you use any accelerators at all?
Yeah. How much? I have no idea. Depending on the weather, depending on... Exactly.
All right, I see the other group.
Yeah, I'm getting too long here, folks. Yeah, they're probably not asking Andy any questions.
Well, he probably wouldn't answer any.
Okay, let's go to the pre-stress side. This plant has been here about 35 years.
What do you use for your form release?
Standard form oil. We use a product made by the Crescent Company, and it's a very high-end form release. And the reason we do it is because if you don't, you start sticking to the form and tearing it.
Yeah.
And at $50 a square foot, you don't want to tear it. That, before we built that building over there, we used to take that and put that over the top of the forms. We have 2 350-foot long forms in the ground on that side. and that kept the rain off of them and everything else, but it made it like a tomb. So we built a building. This little building you see here is everything in the plant that's got an engine is fixed here. We're all self-contained. What was this called, folks? Cribbing. I use dunnage. Cribbing is right. That's another term for it. Dunnage.
Start doing like a point system where every time you answer a question, you get a point, you get a prize at the end of the day.
Yeah, stickers.
Stickers.
Somebody walks in with stickers all over them.
Yeah, I got an ankle. That works. Should work.
4. This area here is called a batch plant. What you're seeing right there is aggregate. Remember the parts of concrete.
Sand.
That bin over there is limestone aggregate. What's in the bin next to it? What else is in concrete?
Sand.
Sand. You see the tan stuff there? There's a sand. They have holes in the floor. And then what happens is a guy says, okay, I need sand. A loader will come over, push that pile over the door, run it up that conveyor, and it has what they call a weigh hopper. And you say, I need 600 pounds of sand. It'll weigh 600 pounds of sand and put it in the mixer. I need 500 pounds of aggregate. It'll put 500 pounds of aggregate. It all goes into that brown building there, and it has a big, huge mixer in there. And then what happens is after they get it all mixed, it's all computer controlled, and the computer says it's done. There's a gate that opens up on the bottom, and it fills up all these different trucks that we have that delivers them to the pouring beds.
And those are trucks that like still mixing.
This is called a pouring truck. You see the bucket on the back over there? Hey, Hollywood. Good. Yourself? Yeah, see the bucket over there? That'll hold 2 yards of concrete, and the guy will take the lever that's on the side and pull the lever and open it up, and it'll fill the bed. It'll walk down the line, fill the bed. Keep just rocking that thing back and forth. The other truck will come and deliver more.
So no pump in this.
No. Remember I told you we recycle our water? The trucks come over to this little pond over here, and you see the different bins? They wash out all the trucks and everything else over here, and then when the water gets up to a certain height, it'll roll over to the next, and then keep rolling over, and once it gets to the very end, it'll be clear, and then that goes right back into the pond.
How long have you guys been recycling the water?
That's about 2 years now.
Okay.
We used to do just a one-stage thing.
What do you do with your backwash?
It goes into that area.
What's that area?
Yeah, the backwash goes into each one of it goes into one of the bins and then just keeps recycling over the, it's got little portholes in there that keeps all the solids on one side, and then the clear water goes over here. Clear water is a misnomer. You wouldn't drink it, but you can use it to make concrete. Okay.
Do you have any use for the wind energy?
We tried to get a wind turbine here on the plant site, but you can't by law. You can't get it within 30 feet of a production facility. So that's why you see all the turbines over there. We gotta get the pre-stressing stuff done real fast because your food is here. All you're seeing here is different types of forms for making beams that go underneath bridges. When you look up underneath the bridge and you see those beams going in there, these are the forms that make them. Prestress Engineering is the largest manufacturer of beams in the state of Illinois.
So this is where like all the government specifications come into play.
Yep. And as you can see, because we're in a downtime right now, we're in the process of building our beds back up.
Is this a corporation?
Yes.
Privately owned?
Yes. Watch your step. Yeah, it is nasty in here. What you're looking at is a pre-stressing bed. This thing, has anybody here seen or heard of the 355 extension that goes down to Route 80 from 55? There's a bridge there called the Des Plaines River Valley Bridge. It went over the IM Canal, the Des Plaines River, and the Illinois Shipping Canal. It's a protected wetland. And what they did is they put a pre-stressed bridge element over, there's over 680 beams on that job. Every one of them was manufactured here. The biggest beam is 10 feet tall by 178 feet long. Weighed 237,000 pounds. Was made in this form here. We take pre-stressing. Remember I told you the difference between precast, pre-stress. Pre-stress now has the wire in the concrete. We take pre-stressing strands, and on those particular beams they had 20 strands per beam. Stretch it all the way down to that end. And they have a bulkhead that sits down there and a cross piece that sits between these braces on the wall. This wall is designed to handle over 3 million pounds of stress. This wall goes into the ground about 18 feet. 18. And inside this is a series of I-beams and tube steel and things like that that are constantly bracing it, because we're pulling like this, the steel, and we're putting all the stresses right at this point in the concrete. And as you can see, it's held up pretty well, that you're not having cracking or anything else like that. 3 million pounds of stress it'll handle.
Now the cables or straps go this direction?
Correct.
So the compression and tension will be this direction?
Correct. Let's go to the next bed over and see a better look at that. This one is now set up for double T's for a parking deck that we're going to be starting to pour in a few months. Hopefully in a few weeks. Other plants will shut down. Right. Okay, if you look along the wall here, remember Andy told you before, all that steel that comes down, it gets fit in between. You see where those steel plates are? The strand goes between those. Depending on the design by the engineer, they may go on the bottom all the way up to the top of the piece there, depending on the height of the beam. And then what they do is they put, how many of you ever seen a movie with planes landing on an aircraft carrier and they grab a cable? That's how they stop. We use those same kind of grabbers, they're called chucks, to hold the strand from slipping through. So we pull the strand by a machine, that's a hydraulic machine over there, it pulls it to that 31,000 pounds per strand. And then they put the chuck on it and it will not allow the strand to go back in. All the way down the line. One strand. So what happens, we pour the piece in here, and then within 18 hours, guy comes by with a torch and cuts the strand. And a piece of concrete that's about 350 feet long, or depending if it's 178 feet, all the way down the line, will actually lift up off the bed. Because you're putting all that tension from that strand will go right into the concrete. And then the concrete becomes compressed.
What's the maximum length that you can pour here?
Well, it's not a matter of what we can pour, it's what we can ship. 180 feet was pretty spectacular. And those pieces, as I said, 237,000 pounds were picked up by these two machines here. This is all poured in place concrete. The walls on the outside are all ours. No, tilt up. Oh, that's a precast, that's like swearing at a precast contractor. All these panels were made in those forms that we saw in the other building. They're all precast. Huh? Yeah. Folks, you don't get an idea of how big these things are, but I'm 6 feet. These tires are almost 6 feet tall. These things, each one of these can lift 140,000 pounds without going into its safety factor. So 280,000 pounds between these two machines. As you can see in the pre-stressed form, epoxy coated bar on the bottom, because that's closest to the, that'll be closest to the bottom of the beam, and they want to make sure that it doesn't start rusting or anything above that. You see the strand that's inside has already been tensioned. And what they're doing right now is they're putting additional rebar that have to go in there, and they're tying it to the strands.
Why are some of the rebars like tilted?
Because they haven't come back yet and straightened them all out.
Oh, okay.
See, what happens is that's what these guys are doing right now. They just put them in loose. They build these as what they call cages, and then when they come down the line, they'll straighten everything out. And then my quality control department will come in and measure everything. Then the state of Illinois will come in and measure everything.
What's in that bucket? What's
Which one are you?
What's in the bucket? Like he was like applying something to the rebar.
He's putting grease. He's putting grease at a certain area because they call that debonded steel, which means they don't want the concrete to bond around the steel at that point.
Okay.
And then what happens is they put grease on it so that when you pour to it, the concrete won't grab onto the steel. Those things that are going across the pieces, this is what they call a box beam on a bridge. They will actually take threaded rod that goes through the pieces and tie the piece that's on that side and this side and this side. They'll bolt them all together and squeeze the bridge together this way. They do this on small county bridges. You won't see that on the big ones on the interstate. They haven't straightened them out yet. That's what they're doing as they come along here. See, they just laid the cage in there.
Okay.
And the cage is loose, and then now they'll come by here and you see all those will be all straight.
Okay. And these two inside are...
That's for they call those transverse ties for pulling the box beams together. This is all the welding here will go on.
It's for welding.
Yeah, they're not welding anything right now. But as you see, what happens is on some of these beams, they're not all straight. Sometimes they have skews at the end. They have to build that skew right in there. And, right. Because the bridge might be going like this. So you don't build them straight like that, you build them all skewed so all the pieces go the same way. Once a piece is manufactured in here, they pick it up, put it on a truck, quality control looks at it before it gets poured, quality control looks at it after it gets poured. They bring it out to the yard and it'll sit out there. And then they'll do any kind of little patching or cosmetic work that has to be done out here. And then what'll happen is quality control will come one more time before it ships, and they'll put a tag on it. They put a green tag on it, that means the piece can go. If they put a red tag on it, that means it's rejected. If they put an orange tag on it, that means it has to be something has to be done to it. Pardon?
If it's passing, they just leave it?
No, they still mark it. If it passes, they put a green tag on it. That means it can go.
Where is PCI?
PCI comes into this plant twice a year, unannounced. They could show up today and say, I want to see all your quality control records. I want to see your batching records. I want to see, your shop drawings, your piece tickets, everything else. Then they evaluate each one of those things. The same day, they'll come out and check our batch plant. They'll check the batch plant operator. They'll see that he's not changing tickets or anything else like that. they'll check all the inspection reports, and then they will physically come out and measure those bars to make sure they're in the right spot. Remember I told you folks, when you cut the strands on pre-stress, it bends up. See that beam, how it's cambered up like that? That's because of the pre-stressed beams or the pre-stressed strand inside the piece. If it didn't have strand in there and it was that long, that piece would go like this.
Under their own weight.
Under their own weight. But when you put pre-stressing in, you're putting artificial stresses into that piece to hold that camber. It's designed to have so much camber in there because when they put a road on top of it, it'll come down to a certain point. And then when the trucks go over, if you're ever on a bridge, bridges go like this. That piece is designed to bounce. Okay? Questions? You ready for the test?
Your precast and prestress pretty much 50-50 of your
No.
operation?
No. This plant it's probably 80% transportation, 20% other products. By other products, I mean housing and stuff like that. Now it's, unfortunately, 100% transportation because the housing market's gone.
It's good that you have both of them.
Yeah, that's one of the reasons why we split our plant up like this, because it gives us the opportunity to go when other people are shut down.